Alright, properties of rational exponents. This is what we did in class today, and I was so amazed. There were so many different, really clever ways that you guys found to solve this. So I thought we could possibly look at a couple ways that you might look at this. The simplest way that I saw was this. It was really cool. Is that you converted this to this. This is what I saw. I saw 6 times 9 is 54. And the third root, what does that come from? That comes from the rule that says the nth root of AB is equal to the nth root of, sorry about that, the nth root of A times the nth root of B. So applied that logic here. They are the same roots. So we just multiplied these and got this as 54. And then, when I saw this, I was like, golly, how is... I guess let's look at this real quick. Then I saw you convert this and said this is 2 to the 1/6 times 2 to the 1/6. I was impressed by that because that was you applying this rule that the mth root of x is the same as x to the 1 over mth power. So I saw you apply that second rule. So I see you're really, really getting your properties of rational exponents down. You multiply this, and this is, right, this would be 2 to the 2/6, so 2 to the 2/6, but of course 2 to the 2/6, 2/6 is a third, so it's 2 to the 1/3. Thought that was real good. Yeah? Then I saw you do this. Just kept converting. You converted this to the same thing, and you said this is the same as 54 to the 1/3 power, and this is 2 to the 1/3 power. And I saw this, and then I was really, really, I guess to say I was shocked is not fair, but I was really impressed because I see you're really, really thinking your way through this stuff. Then I saw you apply this rule, which is this. It's actually this rule backwards. It's that a over b to the mth power is a to the mth power over b to the mth power. But if it works this way, then reflexively it has to work that way. So you started out with this, and that was really cool that you took the rule, the kind of the far side of the rule, because I had said to you earlier, we had talked earlier and said, hey, if you see this, remember you can distribute exponents over multiplication and division, so you can send this here and here, and you figured out, well, if it's already here and here, you can pull it out. So you kind of started here and said, well, isn't this true also? Wouldn't this be the same as a over b to the m? And it is, and now it's really astounding and proud of you guys. So that was really good. So this is the way it ended up looking. So it ended up looking like this. Get this mess out of the way for a second, real quick. All right. So while I'm cleaning up the yard, if you could decide what you think we're going to do up here. What we're going to do here is look. Here we have this thing. It's that same rule that we just looked at down there. And look, 1/3 power, 1/3 power. So we can do this. We can take our 54 over 2 and raise it to the 1/3 power. Look at the rule backwards. If we had started here, wouldn't you have distributed, right? Wouldn't you have done this? Wouldn't you have distributed this exponent to here and then to here? So that's really cool that you knew to do that backwards. Now, what you did here was you did 54 divided by 2 is 27. And you had the 27 to the 3rd power. And then I saw you do this. And then it's starting to kind of blow me away that you guys are really, really getting this. And that this whole thing goes to 3. It goes to 3. That was a really, really cool way to do that. I saw you guys go at it different ways too. Let's start with the same problem. And let's look at how other people did this problem. Most of you started out with this idea. Well, almost all of you started out doing this. You turn this into rational exponents, you multiplied, and you got that. So many of you started out with this 2 to the 1/3 at the bottom. It's kind of your first move. And then I saw some of you do this as your second move here, multiply these two. So you got cube root of 54. And then I saw you do something really cool, was that you multiplied these things and then you refactored it into a more convenient way. So I saw you do this. I saw you do the cube root of 2 times the cube root of 27. And of course the cube root of 27 is what? Yeah, it's 3, right? Why is it 3? Because cube root means what number times itself 3 times, and 3 times 3 times 3 is 27. So the numerical solution for this is 3. And then I saw you take this out of its rational form and put it into its rational, I'm sorry, out of its radical form and put it into its rational exponent form, and it looked like this. And then you had 2 over 1/3. These are factors now. 2 to the 1/3 over 2 to the 1/3 is equal to 1, isn't it? So that bit right here is 1. And 1 times 3 is equal to 3. And your answer matches this way. And I saw you guys do it about 10 different ways. And I want you to know that this is how you get good at this. You take the rules and you just have to mess around with the rules and see if you can make them work. So keep working. I'm going to do another video in just a second and just pick one of the other problems that I thought was really, really interesting and show you how we work through it. How much time have we spent here? We only spent about 6 minutes. So let's just do one more very quick problem. And this one is just this. This one is just the square root of 64 times the third root of 64. Well, the square root of 64 is 8, isn't it? And the third root of 64, does it exist? So I would practice. We talked about this before. You know, I would start with some number like 5 and say, could it be equal to 5? So I'd say, is 5 to the third power equals 64? Well, we know first off it ends in a number that's not 5 or 0, so we know this is not the solution. But let's see if we're over or under. So 5 times 5 times 5 is equal to 125. We're over, right? So now we know that our number is less. Our number is less than 5, but it's greater. It's greater than 1 because the cube root of 1 is 1. So just move down one more and see. Well, is it possible the answer here is 4? So is 4 cubed equal to 64? And 4 times 4 is 16, and 16 times 4, and I would have done this 16 times 4, and I would have done this multiplication out, but it is 64, so this is just 4. And 8 times 4 is 32. So our solution to this problem is 32. So we're getting better at this, and I mean much better. Keep it up, keep it up, keep it up.